Welcome. In this video, I'm going to talk about a practical example of using regular expressions to divide a natural language document up into a structured dataset. And I'm going to be looking at this book here, the Siku Zongmu Tiyao. This is the annotated catalog to the complete library of the four treasuries. And this was put together to accompany the complete library of the four treasuries, which was a collection of texts put together at the behest of the Qianlong Emperor in the 1780s. So this catalog, which describes all 3,400-ish books in the Siku Trenchu, as well as another 6 or so thousand that weren't included, was finished in around 1798. And it's a very interesting work because it contains an enormous amount of bibliographic information in a semi-structured format. So we can use patterns within this book to create a structured dataset, and that's precisely what this video is about. So I have here a copy of that comes from zh.wikisource.org. Now, it's comprised of around 205 or 6 different web pages that I've stitched together to form this document, which I'll upload onto GitHub. And if you see here, in this document, each of these pages are indicated with this phrase next. And so I can pull it back apart into the original constituent pages. And I'm going to do that because these pages are structured in a way that is going to benefit me. So what information do I want to get out of this? Well, I want to know what classification a book was in the 4-category classification. So there are classics, there are histories, there are books by the masters, and then there are collections or belles lettres, okay? And so these are the 4 treasuries or the 4 categories. There are also sub-classifications. So there are about 44 subcategories in this text. On each page of this particular document, we actually have a single category and a single subcategory. So knowing that, we can automatically extract information about every one of these books. So if we take a look at this, it's quite interesting because we have, let's actually start on the second page because the first page is actually a little different than all the others. We have information on the 4 categories, which is right here, and we have information on the subcategories, which is right here, and then we have book titles, length of books, information on authorship, and just a general description of the book. So this is the information we're going to parse out. So why don't we go ahead and get started? So I've already made just an empty script here that I'm calling parse.py that I've saved in the same directory as the Siku Zongmu Tiyao text file. And we're going to walk through this iteratively to make sure everything we're doing makes sense. And I'm going to explain in detail everything that's going on, because working with regular expressions can be quite complex. So we'll start off by adding a doc string here that's going to describe what we're doing. So this script will break apart the annotated catalog and create a CSV file. Okay, so we're going to output this to a CSV. So I need to import the libraries that I need, which in this case is just the regular expression library. I don't need anything else for this. So I'll begin by designing one regular expression, which will look for the Siku category. Then we'll make one that looks for the subcategory, and then one that gets the book information. Okay, so 3 or 4 regexes will be the result of this. So I'll start with the Siku category. So I'm going to add a multi-line comment here to kind of just remind myself of what this pattern looks like. So I've gone through this text and I've identified everywhere where that Siku categorization exists. And it's almost always at the very top of the page, and the format looks like this. We have Juan, which just refers to the scroll. We have a number, a space. Then we have the 4 categories classification right here. We have the word bu, which just indicates that it's one of the 4 categories, and then another number. So I'm going to write a regular expression that matches this pattern. So I'll just say the average page starts with a pattern that indicates the 4 treasuries classification, which looks like this. Okay? In this example, we want to extract the Jing character. Okay? That's simple enough. So regex that matches Siku category. Okay? And here I'll just call this Siku regex. This is going to be re.compile because I want to do this before I need to use it. And I'm going to go ahead and make this a multi-line regex. That way I can annotate every single part of it, and I need to give it a flag that is the verbose flag. So that just lets me have every single part of this regex on its own line. And so the first thing I need to match is this Juan character. And here I'll just indicate that matches scroll or Juan. The next thing I want is a number, but I need to account for the fact that this might be anywhere from 1 to several hundred. So what I'll do is I'll make a character class, and in that I'm just going to have 1 to 10, 100, and 1,000 just in case. So there we go. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 100, 1,000. This should account for basically everything. And I want to be sure that I match this at least one time, but possibly more than that. So this will match numbers. The next thing I want to match is a white space, but I don't always know that it's going to be there, so I'll optionally match a white space. And from there, this is where we're going to match the 4 categories. So I know there are 4 of them. There's Jing, there's Shi or histories, there are Zi, which are the masters, and then there's Ji, which are the collections or the belles lettres. But this is the information I actually want to extract, so I'm going to return this by making it a group, just like this. And then I know that this will always be followed with Bu, the category. And then finally, this is going to be another number. So here I'll just grab this and copy and paste it down here to match numbers again. So this should actually do what we want it to do. So it's important to test this out, because if we don't do that, it's easy to write a regular expression that doesn't work when we're not exactly sure why it isn't working. So let's go ahead and test this out. So the first thing I need to do is I need to load the text into my script. So now we have the text loaded in. Now you may remember that this text is divided into pages, and those pages are going to have important information for us. So let's go ahead and divide the text into pages using the string that I joined it with in the first place. So here, divide text into pages. So pages equal text dot split. Next, just like that. Okay, so now I can handle each page individually. Now I actually know that there are a few pages here that don't have any information that are useful for me, so I'm going to go ahead and get rid of them. So I'll just say, I know that the first page doesn't have anything, and I also know that the last 5 pages don't have anything, just from having played around with this a little bit. So I'm just going to dump them because they're not really useful for me. And now I'm going to iterate through each page, and we'll search for our pattern. So I'll use the Siku regex to search for the pattern. So I'll just say Siku info is going to equal Siku regex dot search, and I'll look for in my page, and I think this has an underscore. Okay. I'm using search because I only need to know if it happens once, and print it if it finds anything. And this returns none if it doesn't find anything, so I need to check first. So I'll print Siku info. Save it. I'll go back here. I'll run it. And it looks like I found what I'm looking for. Now, I should note that the first page actually doesn't contain information in the same pattern, so I'm going to also keep track of what our current values are, because not every page are going to mention them. So I'll start with the current Siku equal to classics, and I'll update that as we encounter new ones. So current value for the Siku category is just that. So now, instead of printing this, I want the group here, and I want group 1 because that is where this Siku value is being placed. And now I'm going to say current Siku equals Siku info.group1, and let's go ahead and print current Siku just to make sure that everything's going as we expect. I'll save this. I'll go back over here and I'll run it, and we can see it behaves exactly as expected. Okay, so I don't need this print statement anymore. Now let's see if we can get that subcategory information. And I'm going to go ahead and put this up here with this regular expression, and I'll say the subcategory information tends to follow one of two patterns. Okay, and I know this because I looked through to find these patterns. I know that it will follow this pattern or this pattern. Okay, so I want to write a regular expression that matches either the first one or the second one, and the information that I want to get out of it is here at Chunqiu or here at Xiao. Okay, so this is a little more complex than what we just wrote, but we can still do it quite easily. I'll call this subcat regex, and this is just going to equal re.compile again, and here we'll once again do a multi-line regex. I'll do re.x for verbose, but I also want to make sure this is multi-line because I want to ensure that this pattern is only found at the beginning of a line, because I know that this pattern only ever shows up there. So this caret indicates that the pattern will appear beginning of a line. Okay, so that'll exclude some other places where this might appear where it's not at the beginning of the line. Now what I want to do is I want to use parentheses to guide the logic of this regular expression, because I know I want to match either or of these things, but I still want to capture information from them. So I want to use parentheses to guide the logic of this regular expression, but I don't want to capture this whole pattern. So what I can do is I can use parentheses, which is how we make a group, but then if I add a question mark colon, this will indicate that the group should not return anything. Okay, so I don't want to capture this particular part of the pattern. So I know that it's going to start with equal equal. So this just matches equal equal. The next part is what I actually want to capture. So I'm going to put this inside parentheses, and I'll just do dot period plus. Match the category value. Okay. The next part, I know that it's going to have the character lei, so I'm going to add that. Matches the character for category lei. And then I know that it's going to have some number, and I can just go up here and steal this because I already have it written out. Paste that. That matches numbers. And then I finish it out with equal equal. Okay? Matches equal equal. And so this will match the first part of this pattern. So we're starting to get where we need to be, but we also want to match this part. So here I'll specify or match this pattern. And so once again here, I want to indicate that this is a non-capture group because I don't need the whole thing. Then I'm going to look for this circle, which I will copy and paste here because I'm not actually sure how to do the circle. So match the circle. Then again, it's going to be dot period plus to capture the value. Then again, lei, that character. And that's actually it. So that is the pattern we're going to be looking for here. So let's go ahead and test it. Save this, and we'll go down here, and I'll test this out. So use the subcategory to search for pattern. Okay, so now we'll say subcat info equals subcat regex dot search page, because there's only going to be one value for this on any given page. And once again, I'll say if subcat info. Then I need to check which group actually captured it, because you'll note that in that regular expression, if we go back up here, I have two captured groups. I have this one and I have this one. And this will return always group 1 and group 2, no matter which part of the pattern it finds. So I need to check which one actually exists. And it'll only ever be one or the other. So I can do this pretty easily by just saying if subcat info.group1, we'll go ahead and print that. Print subcat info.group1, else print subcat info.group2. Okay? And so this should, in theory, provide the information for us. So let's do this, run this again, and you can see, indeed, we have found that subcategory information. So this is working perfectly so far. But instead of printing this, I want to save this as the current subcategory. So let's go back up here, and we'll make a current value for the subcategory. And so I'll say current subcat, and I know this starts with the E category, the changes. So I'll set that, and then down here, what I can do is I can simply say current subcat is going to equal this, and I'll make sure that I do this, get rid of that, and I'll say current subcat equals this. Okay? And so this should, in theory, if I can type this correctly, save the current subcategory. Let's make sure this doesn't have any errors, and we look good. So now let's just test to make sure everything is functioning properly. I'll print current Siku and current subcat. Run this. Works just fine. Okay. So now we have the first two pieces of information. Let's write another regular expression that actually finds the books themselves. Now, these patterns are going to be a bit more complicated, so we need to be careful about how we do this. I'll get rid of this print statement, and I'll start another regular expression. Now, let's write a regex that matches information on books. Now here, there's a lot more variability in the patterns that we need to look for, so this is going to be more complex. I'll show you what the standard pattern tends to look like, which is something kind of like this. Now, this format is essentially this. We have two equal signs, which indicates markup in the original document. We have a open quotation mark. We have these double brackets, a title. We have closed brackets. We have a circle sometimes, not always. I'll just add that here, a circle here. Then we have length, and usually the character gen, and then some curly brackets, a star, a pipe, and then addition information, and this, and then usually book information. Okay, and that's actually just two of these. And this is the general pattern we want to match, although there are variations that we're going to account for. Okay, let's get to it. So what I want to do is I want to start writing a regular expression that will match this kind of complex pattern while also taking into account that there will be variations in this pattern. Okay? So I'm just going to call this book regex, and this will again be recompile. We're going to do the same thing we did. We're going to make sure that this is verbose with our re.x flag, and again running in multi-line mode. We'll scan this down a little bit. Okay. So the first thing we know is that book information always appears at the beginning of a line. So this is just a caret, which will match the beginning of a line. Then again, we have a place where we have these equal signs, just like this. But sometimes there's actually a triangle that starts the book name. And I know you haven't seen this, but if you look through this file, you'll find that this is indeed the case. So what I want to do, rather than having this matches right here, I'm going to go ahead and set up another non-capture group for myself to control the logic of the regular expression. And now I'll match either this equal sign, so match equals, or I want to match this triangle. And I'll just grab this from the side here. So I want to match this triangle. So this will just match that, okay? So, and I'm putting this inside of a group so I can match either the double equals or that triangle. And of course here, this is simply closing the group. We don't necessarily need to add a comment there. And now we want to indicate that there will be an opening quotation mark then the title itself, and sometimes there are those double brackets, but they're not always there, so I'm going to remove the double brackets where they exist in some post-processing. So title, information, and then the closed quotation mark, close quotation mark. Now, of course, if we look at our example here, we can see that we have a circle here, and I'll copy this and put it down here, but in fact, sometimes this is just a space, and sometimes it's neither a space nor a circle. So I will make this a character set, I'll allow a space in there, and I'll make it optional. So that matches the circle or a space, optionally. Okay? From there, we want to identify the length of the text. And this is not something that shows up in every single book, so we want to make sure that this is also an optional match. So again, we'll make ourselves a non-capture group, and then inside this non-capture group, we want to capture the length. So I'll just go ahead and again steal this from above, because I might as well. So I'll grab this, I'll put it right here. This will match the number, and then it'll end with gen, just like this. And I want to be sure that I am going to capture these numbers. And so if this group matches, if this happens, then I'll get that number out of this. And so I'll capture the length. But I want to make sure this is optional because it's not in every book. Now sometimes we have this kind of curly bracket addition information like we can see right here, but this doesn't always occur. So again, I want another optional group, an optional non-capture group, which again looks just like this. I'll go ahead and match my curly brackets. And so these are double curly brackets. So this just matches two curly brackets just like this. And I should keep my commenting habits up. So start non-capture group, scroll, and close it, but match optionally. Again, start non-capture group. There we go, and now matches those. The next thing inside this group needs to be a literal star, and that will match a star. Then we'll need to match a literal pipe, which will just match a pipe. And then we get to the point where we're actually at the information we want. So again, we want to capture it, and I'll just find everything that happens to exist here, and I'll make it non-greedy, although technically this is probably not necessary. So match contents non-greedy and capture. Now I want to match the closing brackets, match that. And then that should take care of everything that is inside those curly brackets, optionally. So close the group and make it optional. We're going to continue because there's more to these books than we've covered so far. In some cases, there are those double equal signs closing it. Here, I'll say equals 2, because I know it's going to happen 2 times. I'm using this 2 notation because I want to make this particular phrasing optional. If I used equal equal, it would only make that second equal sign optional. And so I'll say, optionally match equal equal. Now there's sometimes even more information on the particular addition on the next line. So I'm going to make myself another non-capturing group, non-capture group, that will optionally match this. Okay? And I'll go ahead and say close the group, make it optional. Now inside this phrase, I know that it will be on the next line, so I need a new line character. So this will match a new line. The information will then appear, and I'll just capture everything. I'll make it non-greedy, and that will optionally match that. Finally is the book information. And the book information appears after 2 new lines, and fortunately this text is pretty consistent about that. So match 2 new lines to get to book info, and then I'm going to just collect everything else that's still there. So collect the book info. Okay? And so now I have a regular expression that should match the books. So if I look over this, I can see that there are a few capture groups. The first group matches the title information, and that's right here. The second matches the length of the text right here. The third matches edition information inside curly brackets. The fourth matches extra information that's on a new line, and the fifth gets everything else about the book. Okay, let's test this out. To do this, I want to go down to where I'm iterating through my pages, and I want to extract this information. So I can do this right here. I already have all of my categorical information. Now let's see if I can get the book information. And I'll call this info on books. It's just going to equal book regex. And here I want to make sure I find all of the information. So I don't just want to do a search. I'm going to use find iter to get all of the match objects. And I'm going to run the page through it. So for book info in info on books, because find iter always returns me an iterator object, I need to iterate through it to see if there's anything in it. So here we'll say get book info on each page and iterate through each result. If there is a result, then get it. Okay, so if book info, print book info. Now here in a second, we will try to get more information out of this, but we'll start with just this. So here I'll say python parse.py. I'll run through, and it looks like we are getting lots of information on the books. So this is perfect. We're not going to get every single book necessarily, but we're going to get pretty darn close. So now I can start to tease out the information I'm actually looking for. So I'm looking for title, length, edition information, and the total bibliographic entry. Rather than printing it, I'll say my title is going to equal book info. Remember, that's the first group. My length is going to equal book info, the second group, but it's actually important to know that this might be none, because sometimes this will not actually result in any information because it's not always there. Now I want the addition information, or I'll just call it supplemental, and that's either going to be the third or the fourth group. So I'll show you how I'll handle this. I'll say bookinfo.group 3, and then I'm going to add bookinfo.group 4. Now these might be none, and I can't add none types together, so I'm going to turn these into strings. Then what I'll do is I'll just overwrite this with the same thing, but I'm going to replace none with an empty string. Okay? So there are lots of other ways we might handle this, but this is a relatively reasonable way of doing it. So now I have my title, my length, and my edition information. Let's go ahead and get that book description too. I'll just call it book description equals book info dot group 5. Now, I want to break this down just slightly further to get the author information as well, or rather, at least people who are involved in the text. I could have built that into the regular expression that we just wrote for the books, but I'm going to make a separate one to deal with information in this book description. And I'll leave this much more simple than it could be, both for sake of time and complexity. So what I'm going to do is I'm going to go back up in my script, and I'm going to write another regular expression. And I'll add it right here, and I'll say bibliographic description often contains info on people involved in the production of the book. It usually looks like this. Usually the dynasty that the person lived in is going to be here, their name, and then whatever role they have attached to the text. Now, there might be multiple people mentioned. We're just going to get the first person for simplicity's sake. Let's write that final regular expression. And I'll just say person regex, and this is going to equal, again, exactly what we've been doing before, just like this. And this will also always be at the beginning of a line. So I need to make sure that I'm using the re.x and the re.m flags. So this is the beginning of a line. I'm going to get all of the information about them. I could give a list of dynasties to make sure that I'm extracting that too separately, but that adds significant complexity to the regex I'm writing, and I'm just going to skip that for now. Get the info. Finally, I'm going to add a character set full of the different kinds of roles that are often described in these records, which I have prepped over to my side here, and these are just different roles involved. So we have things like here the first one is wrote, edited, compiled, selected, again another edited, annotated, and narrated. So there's sometimes the person who actually cuts the woodblock is mentioned, but that's fairly rare. We'll just accept for the moment that there's going to be a little bit of information loss as we do this. The last thing I want to do as part of this regular expression is actually capture this. So I get both the information and the role. Get the role. And now we have our final regular expression. This one was much, much simpler. So again, to test it, we'll go into our script, and from our book description, we're going to run this regular expression. So I'll just say get personal info. And I'll say person info is going to equal person regex. We'll just do a search because we're only going to look at the first one, the book description, just like that. And then if we find anything, then we'll know that the person is going to equal the first group, person info. We'll do group 1. And then we want the role is going to equal person info dot group 2. And let's print person and role to see if we've done our jobs properly. Perfect. So this gives us dynasty, name, and role. It, does have some extra information that does make this a little more complicated. Actually, let's refine this and just, instead of doing a greedy search here in our regular expression, right here, let's make this a not greedy search. That way it doesn't give us this extra info. There we go. That is much easier to deal with. So now we have the names and the roles of the people involved. Okay? That basically does it. That's all of the information I want for my spreadsheet. And I have it now in a pretty structured format. So how do I then put this into a spreadsheet? Well, there are lots of libraries that will let us do this in Python, but I'm just going to do this manually. Let's add a couple comments just so it's very clear what's going on. If person exists, save the info. But note that we should also account for the fact that sometimes there's not going to be this information. So I'm going to say else person is going to be an empty string, and role will also be an empty string. That way, when I try to save it, I'm not trying to deal with missing variables. Okay? So let's make a list, and I'm going to call this information, and I'm going to give it all of the different variables. So first, I want the title, and I'll give it the current Siku, the current subcat, length, the person, the role, the supplemental, and then the book description. And I'm retaining that book description because there's lots of information in there that I might want to go back to later. Okay, so now we have a list of information on the current book. So I'm going to need to transform this slightly so it can go into my spreadsheet. First, I'll say information is going to equal string I for I in information. So I just want to make sure everything gets turned into a string. Some of these might be none, and I want to make sure that I handle that, because otherwise it's not going to process properly. Then I'll also want to be sure that I join this with a comma or some sort of separating delimiter. Now, comma is a little dangerous because some of these might actually have commas in them, but I think in this particular case, it's actually all Chinese commas, so I don't need to worry about that. And so now the information is saved as a string, and I can create another variable to store all of the information. So let's just say up here, before I iterate through these pages, I need a variable to hold results, and I'll just call this results, and this is an empty list. Now I will add to the results the information. And one final thing is I want to save it. So I'll say with open output.csv. We'll write it, make sure I'm coding set 8, and as WF. I'll write, and I'm going to go ahead and write something that will function as a header just for my own convenience. I'll say title, Siku, subcat, length, person, role, sup, and description. Okay? And I'll have a new line here just so everything is on a new line. And then what I'll do is I will write my data, which will just be /n.join results. And so now what this should do is this should just go through the file, find all of the matching patterns, and return a spreadsheet. Let's see if it worked. Well, we didn't get an error, so that's a good sign. And I have an output CSV. I'll just open it with numbers because that's the default. And we can see we have the title, the Siku, the subcat, the length, people involved if they're mentioned, and descriptions. Now you'll note that this first one is wrong, and we'll go back to that here in a second. But most of this looks good, but let's go ahead and do that post-processing where we get rid of these brackets around the title. So here, I'm just going to very simply say replace open bracket with nothing, and replace close bracket with nothing. So that should solve that particular problem. Finally, let's take a look at why that first entry is incorrect. And it's because the very first entry in this book is unlike anything else in that it has information on not just a single line, but on multiple lines. So here we see that there is a space, addition information, and then everything. If we delete this line and save it, that should fix the problem. So I'm going to run this parse again. I'm going to quit this and reopen it. And we have it fixed. We don't have those brackets, and that first line is now accurately described. Okay? Well, there you have it. It was a little long and a little complex, but we now have a script that will break apart a very large text into a structured data set. And this is very useful because this particular text is about 3,000 pages long. It takes a long time to go through this one at a time and pick out the information. But now we have it, and we can do some interesting things with it should we choose. So I hope this was informative and enjoyable. You can find the script that we just wrote together online, and the text itself as well. They'll be on GitHub, and the link will be in the description. Okay? Thanks so much for joining me, and I hope you come back next time. Take care.